CIET NCERT presents the audiobook Ganit Prakash, Textbook of Mathematics for Class 6.
Chapter number 3. Number Play. Numbers are used in different contexts and in many different ways to organize our lives. We have used numbers to count and have applied the basic operations of addition, subtraction, multiplication and division on them to solve problems related to our daily lives. In this chapter, we will continue this journey by playing with numbers. Numbers around us, noticing patterns and learning to use numbers and operations in new ways. Think about various situations where we use numbers. List 5 different situations in which numbers are used. What your classmates have listed, share and discuss. 3.1. Numbers can tell us things. What are these numbers telling us? Some children in a park are standing in a line. Each one says a number. You can find a picture of 8 children standing here. What do you think these numbers mean? The children now rearrange themselves and again each one says a number based on the arrangement. Page number 56. Did you figure out what these numbers represent? Hint. Could their heights be playing a role? A child says 1 if there is only one taller child standing next to them. A child says 2 if both the children standing next to them are taller. A child says 0 if neither of the children standing next to them are taller. That is, each person says the number of taller neighbors they have. Try answering the questions given here and share your reasoning. Question number 1. Can the children rearrange themselves so that the children standing at the end say 2? Question number 2. Can we arrange the children in a line so that all would say only zeros? Question number 3. Can 2 children standing next to each other say the same number? Question number 4. There are 5 children in a group, all of different heights. Can they stand such that 4 of them say 1 and the last one says 0? Why or why not? Question number 5. For this group of 5 children, is the sequence 1, 1, 1, 1, 1 possible? Question number 6. Is the sequence 0, 1, 2, 1, 0 possible? Why or why not? Question number 7. How would you rearrange the 5 children so that the maximum number of children say 2? Page number 57. 3.2 Supercells. Observe the numbers written in the table given here. Why are some numbers colored? Discuss. We have 2 columns here. In the first column, we have numbers 43, 79, 75, 63, 10, 29, 28 and 34. Out of these, 79, 29 and 34 are colored. In the second column, we have numbers 200, 577, 626, 345, 790, 694, 109 and 198. Out of these, 626, 790 and 198 are colored. A cell is colored if the number in it is larger than its adjacent cells. The number 626 is colored as it is larger than 577 and 345. Whereas 200 is not colored as it is smaller than 577, the number 198 is colored as it has only one adjacent cell with 109 in it, and 198 is larger than 109. Figure it out. Question number 1. Color or mark the supercells in the table given here. We have a table with numbers 6828, 670, 9435, 3780, 3708, 7308, 8000, 5583 and 52. Question number 2. Fill in the table given here with only 4-digit numbers such that the supercells are exactly the colored cells. Here we have a column in which we have numbers 5346 and there's a blank colored column followed by a blank column without a color. Again comes a number 1258 which is colored, followed by 3 uncolored boxes. Then comes 9635 followed by a colored box. Question number 3. Fill in the table such that we get as many supercells as possible. Use numbers between 100 and 1000 without repetitions. Here we are given blank boxes for the numbers to be written. Question number 4. Out of the 9 numbers, how many supercells are there in the table given here? Dash. Question number 5. Find out how many supercells are possible for different numbers of cells. Do you notice any pattern? What is the method to fill a given table to get the maximum number of supercells? Explore and share your strategy. Page number 58. Question number 6. Can you fill a supercell table without repeating numbers such that there are no supercells? Why or why not? Question number 7. Will the cell having the largest number in a table always be a supercell? Can the cell having the smallest number in a table be a supercell? Why or why not? Question number 8. Fill a table such that the cell having the second largest number is not a supercell. Question number 9. Fill a table such that the cell having the second largest number is not a supercell, but the second smallest number is a supercell. Is it possible? Question number 10. Make other variations of this puzzle and challenge your classmates. Let's do the supercells activity with more rows. Here, the neighboring cells are those that are immediately to the left, right, top and bottom. The rule remains the same. A cell becomes a supercell if the number in it is greater than all the numbers in its neighboring cells. In table 1, 8632 is greater than all its neighbors 4580, 8280, 4795 and 1944. You can find a picture of a box having 4 rows and 4 columns which have numbers 2430, 7500, 7350, 9870. Out of these, 7500 and 9870 are colored. In the second row, 3115, 4795, 9,124, 9,230. In these, none of the numbers are colored. Third row, 4,580, 8,632, 8,280, 3,446. Fourth column, we have 5,785, 1,944, 5,805, 6,034. In this, the last number 6,034 is colored. Complete table 2 with 5-digit numbers whose digits are 1, 0, 6, 3 and 9 in some order. Only a colored cell should have a number greater than all its neighbors. The biggest number in the table is dash. You can find table number 2 here, which has 4 rows and 4 columns. The first block is colored. In the second block, we have number 96,301, then 36,109, and the next block is colored. In the second row, we have a blank box and then 13,609. Then we have a colored box which has number 60,319, followed by another box 19,306. In the third row, we have 2 blocks which are not colored, and the third number is 60,193, followed by a blank block. In the fourth row, we have first block which is not colored. Then we have a colored block with number 10,963, followed by a blank block, and we have colored block after that. Page number 59. The smallest even number in the table is dash. The smallest number greater than 50,000 in the table is dash. Once you have filled the table given here, put commas appropriately after the thousands digit. 3.3 Patterns of numbers on the number line. We are quite familiar with number lines now. Let's find if we can place some numbers in their appropriate positions on the number line. Here are the numbers: 2,180, 2,754, 1,500, 3,600, 9,950, 9,590, 1,050, 3,050, 5,030, 5,300 and 8,400. You can find a picture of a number line with markings from 1,000 to 10,000. On the number line, 2 numbers are marked between 2,000 and 3,000. The numbers are 2,180 and 2,754. Figure it out. Identify the numbers marked on the 4 different number lines given here and label the remaining positions. We have part A, B, C and D. In the first number line A, we have 2 numbers marked here, 2010 and 2020. In the second number line B, we have 2 numbers marked as 9,996 and 9,997. In the third number line C, we have three numbers marked as 15,077, 15,078 and 15,083. In the fourth number line D, we have two numbers marked as 86,705, 87,705. Put a circle around the smallest number and a box around the largest number in each of the sequences here. Page number 60. 3.4 Playing with digits. We start writing numbers from 1, 2, 3 and so on. There are 9 one-digit numbers. Find out how many numbers have 2 digits, 3 digits, 4 digits and 5 digits. You can find here a picture which has 5 columns and 2 rows. In the first column, we have in the first row from 1 to 9. In the first row, we have one-digit numbers from 1 to 9. In the second row, we have number 9. In the second column, we have two-digit numbers, and in the second row, there is a blank. In the third column, we have three-digit numbers, and the row is blank. In the fourth column, we have four-digit numbers, again with a blank in the second row, and five-digit numbers in the fifth column with a blank in the row for the number to be written. Digit sums of numbers. Komal observes that when she adds up digits of certain numbers, the sum is the same. For example, adding the digits of the number 68 will be same as adding the digits of 176 or 545. We have a picture on the right side of the page. 6 plus 8 is equal to 14. 1 plus 7 plus 6 is equal to 14. 5 plus 4 plus 5 is equal to 14. Figure it out. Question number 1. Digit sum 14. Part A. Write other numbers whose digits add up to 14. Part B. What is the smallest number whose digit sum is 14? Part C. What is the largest 5-digit number whose digit sum is 14? Part D. How big a number can you form having the digit sum of 14? Can you make an even bigger number? Question number 2. Find out the digit sums of all the numbers from 40 to 70. Share your observations with the class. Question number 3. Calculate the digit sums of 3-digit numbers whose digits are consecutive. For example, 345. Do you find a pattern? Will this pattern continue? Page number 61. Digit detectives. After writing numbers from 1 to 100, Dinesh wondered how many times he would have written the digit 7. Among the numbers 1 to 100, how many times will the digit 7 occur? Among the numbers 1 to 1000, how many times will the digit 7 occur? Here you can find a picture of a box with some numbers having 7 as digits. The numbers are 237, 57, 877, 7041, 676, 7 and 1799. 3.5 Pretty palindromic patterns. What pattern do you find in these numbers? 66, 848, 575, 797, 1111. These numbers read the same from left to right and from right to left. Try and find such numbers are called palindromes or palindromic numbers. All palindromes using 1, 2, 3. The numbers 121, 313, 222 are some examples of palindromes using the digits 1, 2, 3. Write all possible 3-digit palindromes using these digits. Reverse and add palindromes. Here we have some addition of numbers. Try to figure out what is happening. Steps to follow. Start with a 2-digit number. Add this number to its reverse. Stop if you get a palindrome, or else repeat the steps of reversing the digits and adding. Try the same procedure for some other numbers and perform the same steps. Stop if you get a palindrome. On the right side of the page, you find some additions of numbers as 34 plus 43 is equal to 77. 29 plus 92 is equal to 121. 48 plus 84 is equal to 132 plus 231 is equal to 363. 76 plus 67 is equal to 143 plus 341 is equal to 484. Page number 62. There are numbers for which you have to repeat this a large number of times. Are there numbers for which you do not reach a palindrome at all? Explore. Will reversing and adding numbers repeatedly, starting with a 2-digit number, always give a palindrome? Explore and find out. Puzzle time. You can find here blank boxes for writing the number in figures and words. We have first box with 10,000, second box for 1,000, third for 100, fourth for 10, and fifth one for units place. We have another block below for the number to be written in words. I am a 5-digit palindrome. I am an odd number. My tens digit is double of my units digits. My hundreds digit is double of my tens digit. Who am I? Dash. 3.6, the magic number of Kapraker. D.R. Kapraker was a mathematics teacher in a government school in Devlali, Maharashtra. He liked playing with numbers very much and found many beautiful patterns in numbers that were previously unknown. In 1949, he discovered a fascinating and magical phenomenon when playing with 4-digit numbers. You find the answer to the explore activity mentioned on this page. The answer is yes. For 3-digit numbers, the answer is unknown. It is suspected that starting with 196 never yields a palindrome. On the right side of the page, we have picture of D.R. Kapraker, who was a famous mathematics teacher. Page number 63. Follow these steps and experience the magic for yourselves. Pick any 4-digit number having at least 2 different digits, say 6382. You can find a flow chart with sequence of steps for the activity. The first step is shown in a block as take a 4-digit number. We have an arrow down. In the second block, we have make the largest number from these digits. Call it A. Again, we have an arrow downwards. In the third block, we have make the smallest number from these digits. Call it B. With the arrow downward, we have the fourth block showing subtract B from A. Call it C. C is equal to A minus B. From C, we have an arrow pointing for the second block which shows use digits of C. What happens if you continue doing this? Take A as 8632, B as 2368 and C is equal to 8632 minus 2368, that is equal to 6264. A is equal to 6642, B is equal to 2466, C is equal to 6642 minus 2466, that is equal to 4176. Again take this as A is equal to 7641, B is equal to 1467. So C will be equal to 7641 minus 1467. That is equal to 6174. On the similar lines, you can try on your own, taking A as a number, B as a reverse number and C you will get on subtracting these numbers. Explore. Take different 4-digit numbers and try carrying out these steps. Find out what happens. Check with your friends what they got. You will always reach the magic number 6174. The number 6174 is now called the Capraker constant. Carry out these same steps with a few 3-digit numbers. What number will start repeating? Page number 64. 3.7 Clock and calendar numbers. On the usual 12-hour clock, there are timings with different patterns. For example, 4 o'clock 44 minutes, 10 o'clock 10 minutes, 12 o'clock 21 minutes. Try and find out all possible times on a 12-hour clock of each of these types. There is a picture on the right side of the page for clock and calendar numbers with numbers 16, 02 and 2016. Manish has his birthday on 28th December 2012, where the digits 2, 0, 1 and 2 repeat in that order. Find some other dates of this form from the past. His sister Meghna has her birthday on 11th February 2011, where the digits read the same from left to right and from right to left. Find all possible dates of this form from the past. Jeevan was observed at this year's calendar. He started wondering, why should we change the calendar every year? Can we not reuse a calendar? What do you think? You might have noticed that last year's calendar was different from this year's. Also, next year's calendar will also be different from the previous year's. But will any year's calendar repeat again after some years? Will all dates and days in a year match exactly with that of another year? Figure it out. Question number 1. Pratibha uses the digits 4, 7, 3 and 2 and makes the smallest and largest 4-digit numbers with them as 2347 and 7432. The difference between these two numbers is 7432 minus 2347 is equal to 5085. The sum of these two numbers is 9779. Choose 4 digits to make. Part A. The difference between the largest and smallest numbers greater than 5085. Page number 65. Part B. The difference between the largest and smallest numbers less than 5085. Part C. The sum of the largest and smallest numbers greater than 9779. Part D. The sum of the largest and smallest numbers less than 9779. Question number 2. What is the sum of the smallest and largest 5-digit palindrome? What is their difference? Question number 3. The time now is 10 o'clock and 1 minute. How many minutes until the clock displays the next palindromic time? What about the one after that? Question number 4. How many rounds does the number 5683 take to reach the Kaprekar constant? 3.8 Mental Math. Explore the figure given here. What can you say about the numbers and the lines drawn? We have 4 blocks in the first column, 5 blocks in the second column, and again 4 blocks in the third column. The numbers displayed in the first column are 38,800, 28,000, 61,600, 31,000. In the second column where we have 5 rows, the numbers displayed are 25,000, 400, 13,000, 1,500 and 60,000. In the third column, we have 4 rows with numbers 3,400, 63,000, 19,500, 20,900. We have some arrows pointing from 25,000 to 38,800, 400 to 38,800 2 times, and then 13,000 pointing to 38,800. Likewise, towards the right we have 3 arrows, one pointing from 400 to 3,400 and 2 arrows from 1,500 pointing to 3,400. Numbers in the middle column are added in different ways to get the numbers on the sides. Within brackets, 1,500 plus 1,500 plus 400 is equal to 3,400. The numbers in the middle can be used as many times as needed to get the desired sum. Draw arrows from the middle to the numbers on the sides to obtain the desired sums. 2 examples are given. it is simpler to do it mentally. 38,800 is equal to 25,000 plus 400 into 2 plus 13,000. 3,400 is equal to 1,500 plus 1,500 plus 400. Page number 66. Can we make 1,000 using the numbers in the middle? Why not? What about 14,000, 15,000 and 16,000? Yes, it is possible. Explore how. What thousands cannot be made? Adding and subtracting. Here, using the numbers in the boxes, we are allowed to use both addition and subtraction to get the required number. An example is given here. We have 6 blocks, 2 in each row. In the first row, we have numbers 40,000 and 7,000. In the second row, we have numbers 300 and 1,500. In the third row, we have numbers 12,000 and 800. We can find that 39,800 is equal to 40,000 minus 800 plus 300 plus 300. Likewise, you can try to write 45,000 is equal to dash, 5,900 is equal to dash, 17,500 is equal to dash, 21,400 is equal to dash. Digits and operations. An example of adding two 5-digit numbers to get another 5-digit number is 12,350 plus 24,545 is equal to 36,895. An example of subtracting two 5-digit numbers to get another 5-digit number is 48,952 minus 24,547 is equal to 24,405. Figure it out. Question number 1. Write an example for each of the given scenarios whenever possible. There are 10 boxes. The first box has 5-digit plus 5-digit to give a 5-digit sum more than 90,250. The second block has 5-digit plus 3-digit to give a 6-digit sum. The third box has 4-digit plus 4-digit to give a 6-digit sum. The fourth box has 5-digit plus 5-digit to give a 6-digit sum. The fifth box has 5-digit plus 5-digit to give 18,500. In the second row, we have 5-digit minus 5-digit to give a difference less than 56,503. Next box has 5-digit minus 3-digit to give a 4-digit difference. The next box has 5-digit minus 4-digit to give a 4-digit difference. The next box 5-digit minus 5-digit to give a 3-digit difference. And the last box has 5-digit minus 5-digit to give 91,500. Page number 67. Could you find examples for all the cases? If not, think and discuss what could be the reason. Make other such questions and challenge your classmates. Question number 2. Always, sometimes, never are some statements. Think, explore and find out if each of the statement is always true, only sometimes true or never true. Why do you think so? Write your reasoning and discuss this with the class. Part A. 5-digit number plus 5-digit number gives a 5-digit number. Part B. 4-digit number plus 2-digit number gives a 4-digit number. Part C. 4-digit number plus 2-digit number gives a 6-digit number. Part D. 5-digit number minus 5-digit number gives a 5-digit number. Part E. 5-digit number minus 2-digit number gives a 3-digit number. 3.9. Playing with number patterns. Here are some numbers arranged in some patterns. Find out the sum of the numbers in each of the given figures. Should we add them one by one, or can we use a quicker way? Share and discuss in class the different methods each one of you used to solve these questions. In part A, we have some boxes showing us numbers 40, 40, 40, 40 in the first row, and 50, 50, 50, 50 and 50 in the second row. Third row has 40, 40, 40, 40, and fourth row has 50, 50, 50, 50 and 50. And the last fifth row again has 40, 40, 40 and 40. In part B, we have a grid in two colors which is 8 by 8. The green color has single dot pattern and the other blue color has 5 dots pattern in them. Page number 68. Part C. Here you can find a picture which has 8 rows and 4 columns with numbers 32 and 4 columns and 4 rows with number 64. Part D has grid pattern with 5 columns and 7 rows in 2 different colors, purple and maroon. In these, we have 4 dots and 3 dots alternately. Part E has a hexagonal pattern with some numbers 15, 25 and 35. Part F has concentric circles with numbers 125 in the outermost circle, 250 in the inner circle, and the innermost circle has 1000 at the center and 4 circles with numbers 500. 3.10 An unsolved mystery, the Collard's conjecture. You can find sequences given here. The same rule is applied in all the sequences. Part A 12, 6, 3, 10, 5, 16, 8, 4, 2, 1. Part B 17, 52, 26, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. Part C 21, 64, 32, 16, 8, 4, 2, 1. Part D 22, 11, 34, 17, 52, 26, 13, comma 40, comma 20, comma 10, comma 5, comma 16, comma 8, comma 4, comma 2, comma 1. Do you observe how these sequences were formed? Page number 69. The rule is 1 starts with any number. If the number is even, take half of it. If the number is odd, multiply it by 3 and add 1. Repeat. Notice that all 4 sequences here eventually reach the number 1. In 1937, the German mathematician Lothar Kohlrausch conjectured that the sequence will always reach 1 regardless of the whole number you start with. Even today, despite many mathematicians working on it, it remains an unsolved problem as to whether Kohlrausch's conjecture is true. Kohlrausch's conjecture is one of the most famous unsolved problems in mathematics. Make some more Kohlrausch sequences like those here, starting with your favorite whole numbers. Do you always reach 1? Do you believe the conjecture of Kohlrausch that all such sequences will eventually reach 1? Why or why not? 3.11 Simple estimation. At times, we may not know or need an exact count of things, and an estimate is sufficient for the purpose at hand. For example, your school headmaster might know the exact number of students enrolled in your school, but you may only know an estimated count. How many students are there in your school? About 150? 400? 1,000? Paromita's class section has 32 children. The other 2 sections of her class have 29 and 35 children. So, she estimated the number of children in her class to be about 100. Along with class 6, her school also has classes 7 to 10, and each class has 3 sections each. She assumed a similar number in each class and estimated the number of students in her school to be around 500. Figure it out. We shall do some simple estimates. It is a fun exercise, and you may find it amusing to know the various numbers around us. Remember, we are not interested in the exact numbers for the display questions. Share your methods of estimation with the class. Page number 70. First one, steps you would take to walk. Part A. From the place you are sitting to the classroom door. Part B. Across the school ground from start to end. Part C. From your classroom door to the school gate. Part D. From your school to your home. Question number 2. Number of times you blink your eyes or number of breaths you take. Part A. In a minute. Part B. In an hour. Part C. In a day. Question number 3. Name some objects around you that are Part A. A few thousand in number. Part B. More than 10,000 in number. Estimate the answer. Try to guess within 30 seconds. Check your guess with your friends. Question number 1. Number of words in your maths textbook. Part A. More than 5,000. Part B. Less than 5,000. Question number 2. Number of students in your school who travel to school by bus. Part A. More than 200. Part B, less than 200. Question number 3. Roshan wants to buy milk and 3 types of fruit to make fruit custard for 5 people. He estimates the cost to be 100 rupees. Do you agree with him? Why or why not? Question number 4. Estimate the distance between Gandhinagar in Gujarat to Kohima in Nagaland. Hint provided to you is: explore the map of India to locate these cities. Page number 71. Question number 5. Sheetal is in grade 6 and says she has spent around 13,000 hours in school till date. Do you agree with her? Why or why not? Question number 6. Earlier people used to walk long distances as they had no other means of transport. Suppose you walk at your normal pace. Approximately how long would it take you to go from part A, your current location, to one of your favorite places nearby? Part B, your current location to any neighboring state's capital city. Part C, the southernmost point in India to the northernmost point in India. Question number 7. Make some estimation questions and challenge your classmates. 3.12. Games and winning strategies. Numbers can also be used to play games and develop winning strategies. Here is a famous game called 21. Play it with a classmate. Then try it at home with your family. Rules for game number 1. The first player says 1, 2 or 3. Then the 2 players take turns adding 1, 2 or 3 to the previous number said. The first player to reach 21 wins. Play this game several times with your classmate. Are you starting to see the winning strategy? Which player can always win if they play correctly? What is the pattern of numbers that the winning player should say? There are many variations of this game. Here is another common variation. Rules for game number 2. The first player says a number between 1 and 10. Then the 2 players take turns adding a number between 1 and 10 to the previous number said. The first player to reach 99 wins. Play this game several times with your classmate. If you can figure out the corresponding winning strategy in this case. Which player can always win? Page number 72. What is the pattern of numbers that the winning player should say this time? Make your own variations of this game. Decide how much one can add to each turn and what number is the winning number. Then play your game several times and figure out the winning strategy and which player can always win. Figure it out. Question number 1. There is only one supercell within brackets number greater than all its neighbors. In this grid, if you exchange 2 digits of one of the numbers, there will be 4 supercells. Figure out which digits to swap. On the right side of the page, you find 3 by 3 column in which we have numbers as 16,200, 39,344, 29,765. The second row has numbers 23,609, 62,871, 45,306, and the third row has 19,381, 50,319, and 38,408. In this grid, we have the center number colored, that is 62,871. Question number 2. How many rounds does your year of birth take to reach the Kapreker constant? Question number 3. We are the group of 5-digit numbers between 35,000 and 75,000 such that all of our digits are odd. Who is the largest number in our group? Who is the smallest number in our group? Who among us is the closest to 50,000? Question number 4. Estimate the number of holidays you get in a year, including weekends, festivals, and vacation. Then try to get an exact number and how close your estimate is. Question number 5. Estimate the number of liters a mug, a bucket, and an overhead tank can hold. Question number 6. Write one 5-digit number and two 3-digit numbers such that their sum is 18,670. Question number 7. Choose a number between 210 and 390. Create a number pattern similar to those you found in section 3.9 that will sum up to this number. Page number 73. Question number 8. Recall the sequence of powers of 2 from chapter 1, table 1. Why is the Collard's conjecture correct for all the starting numbers in the sequence? Question number 9. Check if the Collard's conjecture holds for the starting number 100. Question number 10. Starting with 0. Players alternate adding numbers between 1 and 3. The first person to reach 22 wins. What is the winning strategy now? Summary. First point. Numbers can be used for many different purposes, including to convey information, make and discover patterns, estimate magnitudes, pose and solve puzzles, and play and win games. Second point. Thinking about and formulating set procedures to use numbers for these purposes is a useful skill and capacity called computational thinking. Point number 3. Many problems about numbers can be very easy to pose, but very difficult to solve. Indeed, numerous such problems are still unsolved. For example, Collard's conjecture. Chapter number 3 ends here.
Ganit Prakash, you were just listening to this audio book, Textbook of Mathematics for Grade 6. Narration, Swarnlata. Academic Coordinator, Dr. Prakash Vadigar. Technical Coordination, Bati Langlingdo. Sound Recordist, Virendra Rawat. Assistance in Production, Surendra Kumar. Directed and produced by Vimlesh Chaudhary. This audiobook is presented to you by CIET NCERT, New Delhi, India.